In 1994, a computer program beat the human world champion at checkers. And for the first time in history, in 2007, the same researcher proved checkers was mathematically solved. Perfect play always ends in a draw. Both were made it to Guinness World Records. And that researcher spent 40 years at the frontier of AI. And then he retired from academia, went back to an idea he would had in 2017, and launched an AI product that cannot hallucinate and will never use your data. Welcome to Data Science with Sam. This is your host, Sam. My guest today is Dr. Jonathan Schaeffer, Distinguished Professor of Computing Science at the University of Alberta, co-founder of the Alberta Machine Intelligence Institute, former Canada Research Chair in AI, and now founder and CEO of Synsira software solution. He's also a creator of Kind. Jonathan holds 2 Guinness World Records. He's also a fellow of the Royal Society of Canada and the AAAI, and launched Kind in February 2026 with a simple thesis: your data should work for you and only you. Jonathan, welcome to the show. I'm very happy to have a great discussion with you today.
Thank you very much. I'm delighted to be here.
So let's start with the long view, because very few people in this conversation have your vantage point. So you have been working in AI for over 40 years, from early game AI and symbolic reasoning through the deep learning revolution. And now we are in the generative AI era. Looking back across that arc, what did the field get right and what did it get consistently wrong? And what surprises you most about where we ended up?
Wow, that's a lot of information. So yes, sadly, I have the white hair to prove that I've been around for a long time. But when you go back to when I started in AI, the big technology there was something called expert systems. That is where AI was based on talking to humans, trying to extract knowledge from humans, putting it into a database, hard coding the rules. And rules were never exact in the sense that something was always true or something was always false. If it's always true, it's a fact, it's 100%. But in the real world, many things are mostly true or sometimes true. And so all this knowledge was captured, and humans would then tune this knowledge by putting parameters. So like, if you have a headache, 98% of the time it's just take an aspirin and you're fine. But 2% of the time, maybe it's something more serious. Maybe it's a brain tumor. Just because you have a headache doesn't mean that aspirin is the cure. So that's the way it was. And in those days, computing was slow. And so you asked, what we got right. One of the things we got right very early on was we used all this knowledge and we combined it with search and did amazing things with search. You referenced the checkers result in 1994. And of course, people know more about the chess result in 1997. And what was interesting was there it used human knowledge, but it also used massive amounts of computing. And what we got right was the understanding that, wow, as you applied more computing to problems, the AI performed better.
Yep.
If you got to look for a needle in the haystack, if you're looking at a few pieces of a hay per second, you'll eventually find it, but it might take a long time. But if you're using a computer and you can look at millions of pieces of hay per second, you're going to find it much quicker. We discovered that search scaled. Faster programs could do more work. The programs would get better.
Yep.
But on the knowledge side, we were still stuck. Humans were the bottleneck. What happened in the late 80s, the 90s, the early 2000s, particularly with technologies like reinforcement learning, which was sort of a niche technology back then, but now is mainstream, of course, is the discovery that we could get programs to play against themselves or interact with themselves back and forth and iteratively refine some of the parameters so that, a headache, okay, if you have a headache, a human might say 98% of the time is you just take aspirin, whereas a computer would take the data and simulate it back and forth and iteratively refine itself. And it might come up with the answer that, well, in practice, 98 was wrong. It should be 99.8 or something like that. And the knowledge that humans put in was now greatly reduced. We didn't have to figure out all these parameters. But the big revolution really happened, in my mind, with deep learning 15 years ago, where we started actually getting rid of the human knowledge and letting these computers just figure out the knowledge on their own, these neural networks with all of these patterns. And so what we've seen now, particularly with generative AI, is you just throw in massive amounts of data and we don't have to specify all the knowledge. The knowledge is implicit in all the books and videos and documents that these AI programs essentially read. And we've discovered that on the knowledge side, it's now scaling. As you put more knowledge in, these programs get better. And so what we've seen, or I've seen over the last 40 years, is on the search side, we scale. Now, the recent advances are on the knowledge side, we scale. And so with fast computers, lots of data, and now, of course, with the sophisticated algorithms like deep learning and the kind of algorithms that we see in large language models today, we're seeing this hockey stick phenomena whereby AIs are doing amazing things. And did I predict it? Of course I predicted that decades ago. All my predictions are correct, except for one problem. I greatly did not appreciate how fast this technology would arise. I thought these kind of things that we're seeing today were decades away, and I'm blown away, stunned, really impressed at what's happened, particularly since November 30th, 2022. That's the day when ChatGPT came out. I'd seen earlier versions of ChatGPT, wasn't impressed, but on November 30th, 2022, I was stunned at how good it was. So I've seen a lot, I've learned a lot, and I'm never making predictions again because they've always off on the time scale.
No. Thanks, Dr. Jonathan. It's really fascinating, like you mentioned about the knowledge. And I think this knowledge transformed into data. And I, I, I I do believe that, the revolution that we've seen in the big data world kind of also accelerate the AI innovation to respect, because that's helps with getting this model gathering more knowledge and stuff. So that's kind of like my follow-up question. What do you think is that if we take that big data revolution away, would it be possible for AI to come to this stage where it is right now if big data wouldn't have happened?
Maybe the problem is it, that's the way AI started. Is people fundamentally thought that we needed human data, human generated data, and that was very difficult to obtain. And it, yes, over years you could gather more and more data, but these AI systems just didn't perform well, probably because they had a lack of data. And there are many equivalents in science where you sort of reach a tipping point where something happens. You reach a critical point where once you cross that threshold, good things start to happen or bad things start to happen. We can talk about climate change where maybe there's a tipping point where things suddenly get irreversibly bad. In the AI world, yes, we probably could have reached where we are today, but it would have taken a lot longer. By doing what we're doing and using all sorts of different types of data of different quality, which surprises me too, on a massive scale, we've reached a tipping point much faster than I ever would have expected. And once you hit that tipping point, things just take off. And we're in this unprecedented period in human history where technology is advancing leaps and bounds, literally, I would say almost every day, almost every week, because we've never experienced this kind of uh, revolution at this kind of a pace before. So, how we would have done it any other way, I can't imagine.
Yeah, no, definitely. So, moving on to the next question. Yeah, I mean, at the beginning of this episode, I did mention about your checkers program, and that's kind of helped you to get to Guinness World Records, right? So, in 2007, your team solved checkers, like proving perfect play always results in a draw. And you kind of like, it seems like you synthesize across 500 billion positions.
500
So
billion.
billion positions. Okay, that's a lot.
Well,
So what did those projects teach you about what AI can do when the problem is precisely defined?
so, the first thing is clearly going back to my first comment about scaling with computing. Decided I wanted to solve checkers in 1989.
Mhm.
And it didn't happen until 2007. So it's 18 years I worked on that project. No, we're not talking about a researcher who's obsessive compulsive, but maybe just a little bit. So I worked on it 18 years, and it was very clear early on that this would happen. I could solve the game of checkers. And it was just a matter of building the technology that would scale.
Mhm.
And then, of course, over time, computers got faster and the networks became more faster and more reliable. And so you could harness them in ways that you couldn't back in 1989. And eventually I got the problem done. So the point here was all about scaling. I liken it to climbing a mountain. If you want to climb Mount Everest, you don't start with Mount Everest. You start with, a mountain that's nearby and is relatively short in height. And you practice your techniques, you figure out the right ways to climb the mountain, and then you go to a bigger mountain, and then a bigger mountain. And then when you're ready, you do the Mount Everest. And that's the way it is with AI. And in my particular project, it was the same way is how do you start building something that you know that you can do? I mean, climbing out Mount Everest is just a matter of climbing. It just happens to be bigger and a longer and harder climb than other mountains. But this is what AI has done essentially over the years is practice on smaller problems or less complex problems like games, figure out the technologies, but try and design them in a way such that they scale so that you can tackle bigger problems when the opportunities arise. And so for me, it was insightful because I learned the importance of how search scaled. And then the bottleneck was always how knowledge scaled. And I didn't solve that problem. Other people solved that problem, but my band aid solutions certainly weren't publishable, but worked well at the time when you've got small mountains to climb, and eventually worked well when you had big mountains to climb. But of course, other people discovered much better ways for scaling knowledge than we used way back when. And just to put things in context, when I started, uh, the machines I were using were 4 million instructions per second. We weren't talking about gigahertz. We're talking about a few megahertz. And in 1990, I bought my first disk that was 1 gigabyte in size. It cost $5,000 plus tax. I've got a phone here beside me. How many gigabytes are on my phone? And it certainly didn't cost $5,000 for each of those gigabytes. So technology scales, and we've reached a tipping point in AI where the computing and the data and the sophistication of the algorithms are such that we're doing amazing things. I like to call it the technology triumvirate. Lots of fast computing, lots of hopefully quality data, and sophisticated algorithms that analyze the data using the fast computing to turn data into knowledge.
Definitely can't agree more with on that. And for my listeners here, like as Dr. Jonathan mentioned, thinking about how this AI revolution was possible, this is because of the fast computing, scaling up the data, and especially having more, easier access to like the quality data also helps this AI revolution or this large language model state where we are right now. Now, one follow-up question I have, as you mentioned about the Chinook. So if try to draw a difference or kind of like a comparison between Chinook and let's say ChatGPT model, I feel like it's almost a philosophical one. Like the Chinook is, I feel like it's more of a deterministic because it operates in a closed world where every answer can be verified. Whereas the GPT model or any large language model that kind of operates in an open world where most answer can't be, deterministic. So, and I feel like most people building with AI today don't think about that distinction carefully enough because I do feel like there are certain business use cases, especially in the industry world, can still be driven by deterministic cases like machine learning. A traditional machine learning algorithm can solve that. But I do see that nowadays, due to this AI era, everybody just trying to solve something with large language model. But sometimes we probably don't have to do that because the regular algorithms should be sufficient enough. So, what's the message do you have for the business leader or the enterprise leader in their AI journey that how they will find that distinction between whether they're going to use traditional machine learning algorithms or something versus a large language model?
So, in some ways, what happened with Chinook and other game playing algorithms is almost historical. There are lessons that were learned, and they were learned in many areas, including search algorithms and knowledge representation and just using knowledge, and that's great. But you can't even talk about Chinook anymore in with modern AI because LLMs are so fundamentally different.
Mm.
A lot of things that people are doing today, I couldn't do with Chinook because in order to announce that the game of checkers was a draw, there had to be zero error, no possibility of error. Now, there was one point where I had a file that got corrupted, and it turned out there was one bit that it got corrupted in a file. And going back in the logs, the bit got corrupted 2 years ago. Well, calculations build on top of calculations, and I could not tolerate any error. So all those computations had to be redone. Today's AI has a tolerance for error. ChatGPT has educated us. I put the word educated in quotes, that it's okay to have errors. We call them hallucinations, which, by the way, is a terrible word. We're anthropomorphizing these programs. We're in some ways building a relationship with these programs, and I think that's completely inappropriate. That's a different issue. These programs are non-deterministic in a sense. They're dynamically evolving because every new bit of data results in these programs having their training slightly tweaked. And therefore, anything that you do with these programs really has to be put in the context of literally the day that you use it, because tomorrow the program, any one of these LLMs, might actually be different because of the new training model that it might be using. So what scares me is in talking with people in industry, there's a lot of naivety about LLMs, what they can do, what they can't do, what they shouldn't do. And I'm not criticizing senior leaders, but I think that it's really important that everybody who's in a decision capacity get educated about sorry, there are problems with LLMs today. and they're fundamental to the algorithm. The notion of, I'm sorry, excuse me, I'm not sure what's going on. Sorry. There's fundamental problems with these large language models. Non-determinism is built in. There's a certain amount of coin flipping that happens with them, which means an answer today may be different than the answer tomorrow. And it also means that making hallucinations, making mistakes, having errors is something that's not going to go away. We can hide it. And these large language model developers, all of the major companies have, I know that people will find this silly, but I call them band-aids. They have band-aids on these models that hides many of the types of errors. So you can say, wow, the errors in these programs are going down. They're getting much more accurate, but that's because there's a lot of band-aids being applied to fix all sorts of logic and reasoning problems that these programs have. There are fundamental flaws in these programs. There are strengths. What everybody needs to understand is that these are programs, they're like graduate students, they're like articling students or interns. They're programs that can answer questions and give you advice and suggestions and information, but that's it. It's up to you to take the responsibility for ensuring that everything that comes back is correct, because there is the error exists, it will not go away, but somebody has to vet these answers to make sure that they are correct. You don't want to be embarrassed by using these tools to write a document that's full of factual mistakes. You don't want to publicly state something based on something that one of these programs produces and turns out to be incredibly embarrassing for you. You just have to be very careful. They're incredibly valuable tools, but they have to be used in context. What I like to think about AI is not that it's artificial intelligence. I view it as augmented intelligence. We should be using these technologies to augment our decision making. As a scientist, I value having graduate students, but my job is to work with the graduate students and help them become better scientists. They'll give me ideas. I'll find the flaws. I'll help them fix it. And we have this kind of relationship. If I was a lawyer, I would have articling students who would prepare drafts, but ultimately, as the lawyer, I would have to sign off. If I was a professional engineer, all the same thing. So what people need to understand is yes, use AI as a tool. It's a valuable tool, but the proper governance and oversight and responsibilities must be in place so that you avoid basically creating potentially a very embarrassing situation for yourself.
No, definitely love that. Like the way you mentioned about the artificial intelligence. I mean, we need to probably rephrase the term as more of an augmented intelligence, because at the end of the day, AI is also just a tool. It's augment human intelligence to amplify our thought process, making us do more than what we have ever imagined of doing in, last few decades. So I think that's really, resonates with me, and I'm pretty sure some of the enterprise leaders or my listeners would also kind of draw the same inspiration from your words. And thank you for sharing your thoughts and wisdom with my listeners here, Dr. Jonathan. Now, let's talk about your recent AI product, Kind. So, Kind is described as a desktop AI application that builds a private searchable knowledge base from a user's own files with no internet access, so no hallucination, and no data ever leaving the device. So just walk us through that. How does it actually work under the hood? And what did you have to sacrifice to make accuracy and privacy non-negotiable constraint rather than just a trade-off?
First, thank you for asking that question. Let me just give a little bit of context. I have files on my computer that they're private to me. I don't want to put them in the cloud. I don't want to add them to a query to a chatbot and a large language model. The reason is because my data is valuable to me, but it's also valuable to the trillion-dollar companies that offer these large language models or cloud storage, because data is knowledge, and
Correct.
these companies can train from my data. They can train from how I access the data. They can even train from what kind of queries I ask. Fundamentally, privacy is important to me. There are things that I put in the cloud, and that's not a problem. But there are things that are important to me that I don't feel I have enough trust with external AI companies to guarantee, absolutely guarantee the privacy. I have a company. There are things that I don't want in the cloud because I don't want my intellectual property, for example, suddenly appearing somewhere else, just like a writer or an artist who probably doesn't put their data, their creative works in the cloud for the same reason. So this is sort of running counter to what most people are doing these days, and they're willfully putting all their data in the hands of a relatively small, large cadre of very large companies. We built a local AI. It runs on your desktop. You create what we call a collection, and you put into it whatever data you want. We're data agnostic. It could be text files, it could be videos, it can be documents, whatever it is. And we take advantage of the fact that you've got probably a really powerful computer that's sitting idle 99% of the day. My mother has a wonderful computer, but she uses it for email and for web browsing. Where do all the extra resources go? They sit there idle. So why not take advantage of your own computer to do your own local AI processing? And with that, we can do some very powerful processing on your machine, taking your data, putting a wall around it so that it never goes off your machine to the internet. It's a matter of privacy. It's also a matter of environmental concern, because I believe in data centers. I know that we need data centers to power much of the world's computing. But with AI, we're in a data center mania where we're creating and building data centers like they're mushrooms. They're sprouting up all over the world. And maybe we don't need all that data center computing. Why not use your own local computer instead of using the data center computing? You won't have to send tokens. You won't have to pay monthly fees. So that's fundamentally where Kind is coming from. We want a private environment, and it's environmentally responsible. But further, since it is your data, we only want to answer questions about your data using your data with no external biases or influence. And that's what we do. We put guardrails in place. So we can do an in-depth analysis of your data. Yes, we do use small models to help us take queries and that you make on your data, to turn the facts that we discover from your data into grammatically correct sentences. But all the answers that come back are fact-based from your data and all fully cited. And part of the technology is absolutely standard technology. It's based on a technology called RAG. But we've, of course, added our own internal guardrails to make sure that we don't use external influences and give you answers that are accurate with respect to your data. Now, of course, if you ask questions and the answer is not in your data, then we simply say we don't know, which is kind of nice. There are some I've had some chatbot experiences where they, excuse me, never seem to admit that they don't know. But also, your data is your data, and if your data is crap, the answers that will come back come from your data, and they may be crappy answers. But my experience is that most people's data is usually high quality. High quality. You've been curating it. If there's stuff that's not of interest, I delete it. So my collections of data are very high quality, and I want answers from my data. And some examples, uh, I have a collection of all my medical data. I certainly don't want that to go to the internet, but I want to ask questions about my medical data without any hallucinations. I have found information about my family, videos, pictures, documents. When I ask questions about my family, I want it from my data with no hallucination. I just wrote a book. All the text, all the references, all the source material that I used for the book, I created a collection about, and I could ask questions about it. And I don't want hallucinations. I'm writing a book. I don't want to query some internet based resources and get information that's potentially inaccurate. That would look really embarrassing in my book. So these are some of the ways that I personally use Kind to ensure that I can extract high quality information from my data. And yeah, there's all sorts of other AI tools that I use that have nothing to do with Kind. Yes, I use Gemini and ChatGPT and Claude, because there are lots of things in the world that I find those tools useful for. But when it comes to certain things like my family history or medical history or my book or my intellectual property, I want to protect it. And Kind puts a wall around it and allows me to get the kinds of quality answers that I need from my data.
Yeah. Thanks, Dr. Schaeffer. And what I would say that my thought process here that at the end of the day, like you mentioned, your data, you have more than 100% rights on it. You don't want that data to be like sitting on like a cloud platform and stuff, right? And there's one thing kind of like just I got that feeling that, especially in the academic area, a scientist, a researcher, when they're working on a certain scientific discovery, they don't want their data to go out. They don't want to bounce ideas with Claude or GPT or Gemini. And I know for a fact because my better half is also a scientist. So in those kind of cases, I guess the kind of AI solution you are recommended here is the go-to for a scientific researcher who does not want their idea to go out and the cloud platform or outside, but they still want to leverage an AI to bounce ideas. Maybe a local AI solution is the way to go. So the data would reside in their laptop, in their system, but they can also kind of harness the power of AI to kind of like get some augmentation on their, human intelligence. I think
Yeah.
that's, I feel like one of the biggest, I guess, use cases. And of course, there will be a lot of use cases I could see in the financial services. Someone like myself, been in the financial service and healthcare world for a long time, where we do have PII data and PHI data restrictions. And those kind of cases, I feel like sometimes we do need to tend to pivot to some local AI solution just to safeguard our data and especially put more guardrails around our systems and data in general.
Let me give another example. One of our biggest users is a photographer, and he's taken the photos and he owns them, and he doesn't want to put them in the cloud. He doesn't want potentially other AI systems or other usage tools to use his data in ways that he doesn't intend. He wants the data on his computer analyzed by the AI, our AI, so that he can find things. He's got hundreds of thousands of photos, right? It's challenging to look through that. And who's going to do that? Well, Kind can do it because we can do an in depth analysis of all of his photos because we're using his computer. Even when he's sleeping, we're doing all the analysis he wants and he finds it incredibly valuable. We have artists who are drawing pictures. They don't want to put them in the cloud. They want their artistic works on their machine. And some of them are ideas. They're like research, right? Here's a draft of what I think this picture might be, and here's the second draft and the third draft. And eventually they'll get to their finished product. And maybe then something might go into a public forum. But again, you want to have the power of AI and use the incredible advances that are happening today but you want to do it with guaranteed privacy. And I'm sorry, I don't trust the internet. I don't trust putting my files in the cloud. I don't trust how the internet might be monitoring me and training based on my queries and what sites I go to and how I search the web. I don't want that information out there. There's a saying that says the internet knows you better than you know yourself. And I
Yeah,
find that
for
a
sure.
truly scary thought. And so, in a small way, kind of allows me to retreat into myself and not have the internet know so much about me.
Yeah, no, definitely. I totally agree with you, Dr. Schaeffer, on that comment on internet knows me better than I know myself. So that's especially in today's world. If you go to social media, you see all those ads targeting you about something that you felt like buying, and somehow internet already knew that you are thinking of buying something, and it starts giving you ads relevant to that. So one thing I wanted to ask is,
I'm just going to throw an
mm,
interjection in there. It's more insidious than that because this just happened a few weeks ago. I did a search for something that I was looking to purchase, something rather esoteric because I collect certain things. And okay, I'm using a search engine because I want to find something there on the internet. Within 24 hours, a company that I'd never heard of, didn't know anything about, sent me an email with that product that I was looking for, which meant the search engine had discovered this, and this information had probably been sold to another company who then contacted me trying to make a sale,
yeah,
which means I am a guinea pig in the internet. Data is being gathered about me. It's being sold or passed on to other companies who are then trying to get me to spend money on their sites. And of course, there'll be a kickback to the search engine company that passed on that reference, right? So I object to that. Now, look, I'm not a Luddite. I use the internet, but I think we all need to be aware that everything we do on the internet is being monitored, is real data. Everything we do is a transaction, which is data, which can be used for training, whether it be for product placement or advertising, or whether it actually provides fuel for large language models,
yeah.
whatever.
No, totally. Now, speaking of large language model, actually, that's kind of related to the question I wanted to ask you. So, for your product kind, the what's the behind the scene large language model? Is it something that you build from the scratch, or is it something like you downloaded data from some different sources and kind of like build a model from the beginning?
So we don't build models, we don't train models. Building models, that's that's being commoditized now. A few years ago, wow, people, big companies were building these incredible models. That's great. But these models have been improved. They've been, they've shrunk in size. Uh, the open source community is building extremely powerful models. So what we use in Kind is we do use an open source model. And when you download Kind, which is an executable, you also end up downloading an open source model. It's just the model. All the other AI around Kind that uses the model, does the analysis, responds with your query, etc. That's all done within Kind, and a lot of it is our own
Got it.
intellectual property.
Got it. And one follow-up question, and I'm not don't want to try to take this discussion very technical, but since you mentioned RAG, and when let's say I install Kind on my laptop, so what would happen to the data? Was there like a vector database that I need to kind of like, tie that to the executable file, or is it where that vector database resides?
Yeah. There's an executable and there's a model that gets downloaded, and that's it. And everything else happens behind the scene. And yes, as it happens, I'm running Kind in the background now, and it's
Mhm.
actually analyzing for one of my projects, which has intellectual property, and it's actually analyzing 1,000 images as we speak.
Okay.
And what we do is every file that gets analyzed, we do it in depth
Hmm.
and we add it to a special database that we've created that contains all of this information. And I can ask questions. And obviously, we go to the database to extract the relevant information and build our answers. So we have our own proprietary database,
Therapist. Okay.
which reflects the deep analysis that we've done of the files that you've put into your kind collection.
Got it. And as an user, I can always ask for those analytics, right? Like what I'm pretty sure, like as I'm downloading Kind to my laptop, and if I'm interacting with Kind, the data is getting stored somewhere, on your side in the database, and user can always obtain their consent, or they can always ask for the analytics from the data,
Uh,
right?
yeah, this is your data, and all we're doing is providing analysis for it, and you can
Got
see
it.
the analysis. There's nothing hidden. One of the things that I like about Kind for me
Mhm.
is that I guess I'm a geek, and so I'm obviously watching what's happening in the world. Today ChatGPT might have the best frontier model, and maybe tomorrow it's Gemini, and maybe next week it's Claude. But oh no, Claude's really good at that, but we should be using Llama for this, whatever. You know, there's so much jockeying. It's like a race, and
It's a race. Yeah.
there are so many different competitors, and sometimes they're in the lead, and sometimes somebody else is in the lead, and back and forth. And there's different races, like who's the best coder and who's the best research LLM, whatever. And that's okay for me because I'm a computer scientist. So, this is really cool stuff that's happening. But all the people I work with, not within the company, but that I interact with socially or whatever, they don't know. They don't care. And so, one of the things that we like to say about Kind is that you curate your data. We, Synsira, curate the AI. And what that means is you've built a data set. Maybe it's about your family. Maybe it's about your finances. We have one person who has their own custom database of all the stocks that that they're interested in following, because they want to buy and sell and make money. Great. You've curated your data, but you don't need to know what the best model is today. And whatever that model is, it may be the best model might be different tomorrow. And so one of the nice things with Kind is that we curate the AI, which means we're all continually improving our AI algorithms and adding in more AI functionality. And we're also watching the models. The model that you would get if you downloaded Kind today is different than the model you would have got if you'd done it 3 weeks ago. Why? Because we felt 3 weeks ago that there was actually a better model on the market now, an open source model. And so we swap in this new model because we feel it does a better job. And who knows, maybe next week there'll be an even better model. We don't want you to spend the time understanding, should I be using this one or that one or whatever. We want to abstract that away because we want to make this as simple a process for you. It's our responsibility to ensure that you get the highest quality AI experience on your desktop.
Yeah. No, totally. Thank you for sharing this level of detail, especially for my listeners. And I would definitely encourage my listeners to check in the show notes where we will share more details about Kind product. Now, kind of like the business end of this episode, I would have like one last question for you, Dr. Schaeffer. You have written about AI and digital sovereignty, the idea that non-US countries are becoming dangerously dependent on AI infrastructure, which they don't control, but it's kind of built by companies that have access to their data. Like we discussed about that, all the big techs, all this race going on, and the data is out there, internet, which they're using to train their AI models. So, in your opinion, how serious is that risk, and what does a healthy AI future look like?
Wow. Okay.
I don't think so that's possible in today's world, given all the data security
All
is
right.
being
Look,
compromised.
I'll be candid. In the last year and a half, the world has changed. I live in Canada, and we've had a very strong relationship with the United States. But things have happened in the last year and a half that have shaken Canadians to the core about our relationship to the United States. I have colleagues in Europe who have the exact same attitude. And when I say colleagues, I'm not just talking about academics, I'm talking about industry people, political people. People are suddenly realized that we, collectively, the rest of the world, are heavily dependent on a small number of very large US companies that have access to and control of our data. And one of the things that most people don't think about is reading the user agreements. Have you ever read the user agreement for any of these major companies that you probably use and maybe have a free account, whether it be for cloud storage or for using for chatting or whatever? When you read these user agreements, first of all, you become extremely frustrated because they're all convoluted and hard to read, and you really need
All
a
legal
lawyer
jargon.
to
Yeah.
understand them. But ultimately, when you get through them, if you understand them, you see that there's all sorts of ways that data that's in the internet that you think is private can be shared or accessed by the US government or other entities under certain circumstances. So, this is a risk in that if a lot of the world's data is housed or used or accessed by a small number of companies, which are largely US based, that's a risk. In Canada, we're very conscious of the fact that there are currently and plans for more tariffs in place. And, what if the US put barriers on digital transactions, not just cross border goods and services? What about cross border data transactions? That could put a country like Canada at big risk. It certainly could put Europe at enormous risk. So, digital sovereignty is important. There has to be a way that we can maintain intellectual property, put it in the cloud, and guarantee and ensure that it stays within our purview, whether it be on our desktop, whether it be in our company, whether it be in our country. Because right now, for many people, the default is just to put it in the cloud, and that has all sorts of unforeseen or unanticipated caveats for many people. So I think it's important. The Canadian government thinks it's important. The European Union thinks it's important. And so you're going to see a lot more independence digitally from all of these countries by having AI infrastructure and data infrastructure that's physically located in the country and governed by the country to ensure that data that needs to stay within the country does indeed stay there.
Yeah. No, definitely. Thanks, Dr. Jonathan. Now, we are kind of like at the towards the end of this episode. So this has been one of the most grounded conversation I've had on this show in last few months. So thank you for your perspective, sharing your wisdoms with my listeners. Now, just a final question before we wrap up. If my listeners want to stay connected with you, continue the conversation, or even if they want to know more about Kind, how would they reach out to you? What's the best medium to connect with you?
Well, there's two ways. First of all, we have a website, synsira.com, Synsira.com. And you can read about the company and Kind. You can purchase Kind there. You'll see that there's a free version of Kind, so you can do a test drive if you want to give it a shot. And we would encourage that. We'd love people to test drive it and send us feedback. And I'm in various media. I have email. I'm on LinkedIn. I certainly would love to connect to people and talk. AI is in my blood. I love talking about this stuff. I think that if we do it right, AI is going to have an incredibly positive impact on the world. I say if we do it right because there's a lot of unknowns there right now, and of course we as a world are grappling with some of those unknowns. But I'm fundamentally a really optimistic person, and I would love to talk about the goods and the bads about this AI revolution.
Thank you, Jonathan. Love the way you finished it. Like the AI, if we figure out how to do it right, we can definitely leverage its power. So responsible AI is the way to go.
Thank
For
you.
my listeners, if you ever had a document you wished you could just ask questions to, but it will stay on your computer, then you know whom to reach out. So check out Kind. All the shows links are on the show notes. And thank you, Dr. Jonathan, once again. And this is worth like 45 minutes of discussion with you. And I'm Sam Day, host of Data Science with Sam. So if you like this episode, please don't forget to subscribe to my channel and also follow me on Podbean, YouTube, Spotify, Apple, Amazon Music, or even iHeartRadio. I'll see you in the next episode. Thank you.